Assalamualaikum and a very good day everyone. This year 2025, together with my supervisor Dr. Hisham Nooh, we are going to present our research project. We are both from Universiti Teknologi UiTM Shah Selangor and Kuala Pilah Negeri Sembilan. Now, let's dive deeper into our research project. I am very excited to present our research project registered under ID RSST007 entitled Development of Mushroom Protein Hydrolysate as Flavour Enhancer, its Physicochemical Properties and Sensory Acceptability. Let's now take a closer look into the study. Due to the emergence of natural and sustainable sources of food products, it has promoted the search for both novel ingredients and matched functionality and sensory appeal. Mushroom protein hydrolysates (MPH) represent a promising approach for creating natural flavor enhancers as they utilize enzymatic hydrolysis to break down mushroom proteins into peptides and amino acids, which is the reason for their umami taste and overall palatability. Therefore, the incorporation of MPH as a natural flavor enhancing greatly fit the current trends that offer an alternative to monosodium glutamate, MSG, and other artificial additives. Therefore, there are two main objectives for this study. First, it is to evaluate the physicochemical properties and compound profiling of mushroom protein hydrolysates (MPH) prepared from Agaricus bisporus and Pleurotus austratus. Second is to assess the sensory acceptability of chicken soups incorporated with different levels of MPH, 3% and 5% compared to monosodium glutamate (MSG) using a 9-point hedonic scale. This is the overall experimental design of this study. It begins with sample preparation, followed by enzymatic hydrolysis and the production of mushroom protein hydrolysate powder through freeze drying. The flow then continues with physicochemical analysis and finally sensory evaluation. Here is the sample preparation process. The mushrooms were cleaned, sliced, blended and filtered, then subjected to enzymatic hydrolysis with bromelain. After hydrolysis, the enzyme was inactivated, followed by centrifugation, and supernatant was freeze dried to produce the powdered mushroom protein hydrolysate. For the analysis methods, several physicochemical and compound profiling tests were carried out. The degree of hydrolysis was determined to measure how much protein was broken down into smaller peptides. Basic proximate analyses such as moisture, crude protein and ash were conducted using standard AOAC methods. In addition, pH and color measurements were taken to understand the stability and visual characteristics of the hydrolysates. For compound profiling, amino acids were analyzed using HPLC, while volatile compounds contributing to flavor and aroma were identified using GCMS. This slide shows the chicken soup formulation used for sensory testing. We standardized the samples by adding 3.33 grams of mushroom protein hydrolysate per 100 grams of soup, which matched the 3% MSG as reference. The amount was adjusted based on each sample's dry matter content. For example, 1.5 liters of soup, this is about 49.95 grams of MPH with exact amounts calculated for Agaricus bisporus and Pleurotus austratus. Other ingredients like broth powder, salt and spices were kept constant. Now, I will move on to the results and discussions. To make it clear, I have divided the findings based on the research objectives. I will begin with the first objective, which is to evaluate the physicochemical properties and compound profiling of mushroom protein hydrolysates from Agaricus bisporus and Pleurotus austratus. According to Table 4.1, the yield of mushroom protein hydrolysate from Agaricus bisporus was slightly higher than Pleurotus austratus. However, statistical analysis revealed no significant difference between the two samples, but it indicates a similar level of recovery under identical extraction and hydrolysis conditions. This suggests that the extraction and enzymatic process using bromelain was effective across both mushroom species. Despite structural differences in their cell walls, both substrates allowed sufficient protein release and recovery when subjected to the same promising parameters. The degree of hydrolysis (DH) was highest in MSG, followed by Agaricus bisporus and Pleurotus austratus. Agaricus bisporus exhibited significantly greater hydrolysis compared to Pleurotus austratus under identical enzymatic conditions. A higher degree of hydrolysis indicates greater cleavage of peptide bonds that result in a higher release of free amino groups. This suggests more effective protein breakdown in Agaricus bisporus, which may contribute to improved flavor development through increased release of flavor-relevant compounds. For moisture content, Pleurotus austratus recorded the highest moisture content, slightly more than Agaricus bisporus, while MSG had a minimal moisture. The moisture content recorded in both mushroom protein hydrolysates falls within the recommended range of 5 to 8%. The higher moisture content in mushroom hydrolysates is related to the inherently porous and fibrous structure of mushroom tissues, which has been reported to affect drying behavior and moisture retention. Lower moisture in Agaricus bisporus compared to Pleurotus austratus may offer an advantage in product shelf life and powder stability during storage. In contrast, MSG being a crystalline and chemical pure compound exhibited negligible moisture as expected. Next, crude protein was highest in MSG, followed by Agaricus bisporus and Pleurotus austratus. Agaricus bisporus contains significantly more crude protein than Pleurotus austratus, suggesting a higher concentration of potential flavor precursor. The higher crude protein observed in Agaricus bisporus provides a greater substrate pool for enzymatic action, which aligns with its higher degree of hydrolysis. For ash content, MSG exhibited the highest ash content, reflecting its pure and salt-based nature. Agaricus bisporus had more ash than Pleurotus austratus, suggesting a slightly higher mineral concentration. Although not flavor active, ash content contributes to the nutritional profile and may influence the perceived saltiness of MPH. Higher ash content usually indicates more total soluble minerals in extract or hydrolysate, which increases ionic strength and affects the taste perception. Enzymatic hydrolysis decreased pH significantly in both mushrooms as indicated by the arrow left to right change within each row of table 4.6. Agaricus bisporus hydrolysate showed a greater reduction in pH from pH 6.19 to pH 4.11 compared to Pleurotus or Stratus hydrolysate from pH 6.30 to pH 4.99. The larger pH drop in Agaricus bisporus suggests more extensive protein or peptide breakdown, releasing more acidic compounds. Before hydrolysis, both slurries were similarly near neutral. After hydrolysis, Agaricus bisporus was significantly more acidic than Pleurotus or Stratus, aligning with other indicators of higher hydrolysis activity like pH. A similar relationship between pH decline and pH has been reported in other enzymatic protein hydrolysis studies where progressive cleavage of peptide bonds liberates carboxy groups that contribute to increased acidity, reported by Zhang 2022. In color analysis, the first parameter is the L value, which indicates lightness. MSG had the highest value, indicate a lighter appearance, while Agaricus bisporus had the lowest value, appearing the darkest. The darker appearance of Agaricus bisporus may be attributed to natural pigments such as melanin-like compounds, phenolics or carotenoids, as well as non-enzymatic browning reactions like Maillard reaction or caramelization during hydrolysis. This may not be desirable for clear soup formulations where a lighter appearance is preferred. Next, the A values, which reflect the red-green axis. Agaricus bisporus showed the highest A value, indicate a noticeably redder tone. Both Pleurotus or Stratus and MSG had negative A values, which reflect a slight greenish tint. The highest redness in Agaricus bisporus could be linked to higher concentrations of browning reaction products such as melanoidins, as well as possible retention of anthocyanin-like or phenolic-derived pigments that intensify red tones during hydrolysis. A reddish tone in Agaricus bisporus may visually support the perception of cooked or seasoned food products with savory applications such as gravies, marinades or meat analogues where richer color is a desirable quality. In terms of B values, which represent the blue-yellow axis, Pleurotus or Stratus showed the highest B value, indicating the strongest yellow coloration among the samples, while Agaricus bisporus also demonstrated a noticeable yellow hue but significantly lower than Pleurotus or Stratus. MSG had the lowest B value, indicating a much less yellow appearance. The higher yellowness in mushroom hydrolysates may be due to natural pigments or mild Maillard reaction during enzymatic hydrolysis. This yellow coloration can enhance the visual appeal of several products, giving a broth-like or stock-like appearance. Now, we will move on to compound profiling, beginning with the amino acid composition. Among the umami-contributing amino acids, aspartic acid and glutamic acid were significantly more abundant in Agaricus bisporus than Pleurotus or Stratus and MSG, suggesting a stronger savory flavor potential. In terms of sweetness amino acids, alanine, glycine and serine were also higher in Agaricus bisporus, contributing to sweetness and taste balance. Moreover, bitter amino acids such as histidine, valine, leucine and isoleucine were elevated in Agaricus bisporus compared to Pleurotus or Stratus, which contribute to a more complex taste profile. Although bitterness is not always desirable, it can complement umami notes and add depth to savory foods. Furthermore, the most abundant aromatic amino acids, phenylalanine and tyrosine, were detected in Agaricus bisporus, important as precursors for aroma compounds. Overall, total amino acids were highest in Agaricus bisporus, followed by MSG and Pleurotus or Stratus, indicating more extensive protein hydrolysis and greater flavor compound availability in Agaricus bisporus. Next is the volatile compounds for Agaricus bisporus. In Agaricus bisporus hydrolysate, fatty acid esters such as 9-hexadecanoic acid and its-methyl ester dominated the volatile profile. These esters are linked to fatty and creamy notes which are typically of mushroom flavors. The presence of phenol 2,2-methylenabis suggests contributions to bitter and woody undertones. While detected mainly in Agaricus bisporus, similar volatile compounds occur in other mushrooms, enhancing their aromatic complexity. For volatile compounds of Pleurotus or Stratus, it is also dominated by fatty acid esters. These esters contribute to a mild and creamy flavor. Higher concentration of phenolic compounds, especially 2,5-dihydroxybenzoic acid compared to Agaricus bisporus. This phenolic compound adds bitter and astringent notes, balancing the flavor profile. Phenol 2,2-methylenbis also present, giving woody and spicy undertones typical of Pleurotus or Stratus. That concludes the findings for the first objective. Now, I will proceed to the second objective, which is to assess the sensory acceptability of chicken soups incorporated with different levels, 3% and 5% of MPH compared to monosodium glutamate MSG using a 9-point hedonic scale. The sensory analysis findings show that mean scores were generally below 6, indicates that panelists found samples acceptable but did not strongly like them. MSG had higher scores across attributes consistent with its non-flavor enhancing power. Among MPH samples, Pleurotus or Stratus 3% achieved the highest umami and overall acceptability compared to the Agaricus bisporus sample. Pleurotus or Stratus 3% showed comparable ratings to the plain control across most taste attributes. Although not significantly higher, the Pleurotus or Stratus 3% samples were consistently close in scores. This suggests that the sensory experience of mushroom-based hydrolysates is still novel, as the use of MPH as seasoning is not yet widespread. It is possible that the lower ratings were partly due to unfamiliarity with these mushroom flavors. In conclusion, our first objective showed that Agaricus hydrolysate had higher degree of hydrolysis, good protein, ash content and total amino acid concentration compared to Pleurotus or Stratus, which suggests stronger flavor enhancing potential. For the second objective, although MSG remained the most preferred, Pleurotus or Stratus at 3% concentration showed the best acceptability among mushroom samples, highlighting its promise as a natural flavor enhancer. That concludes my presentation of this study. I would like to thank my supervisor, my family, department staff and everyone who supported this work. Thank you very much for watching. If you have any thoughts or questions, you are welcome to contact through the details provided.